Hello, my name is Sylvain Poirier, I am French, and I developed the site settheory.net, where I try to share my understanding of mathematics and physics just freely by myself, outside any institutional framework. In this video, I will introduce myself and the motivations for the development of this site. I will tell some observations about the academic system, why it didn't make sense for me as a student and still not as a university teacher, and why it seems to be a worldwide problem. And that's why, if you are deeply interested in mathematics or physics, you wish to learn relativity theory and quantum physics, you might also rather avoid formal education and decide to learn by yourself. Or maybe we can try to do something together. First, something about my life. I was passionate about mathematics and physics since teenage. At 13, I read Einstein's book on relativity. After 1 year struggling with the Lorentz transformation formulas, I found that they could be simplified by diagonalization in light coordinates. I was quite excited about this sort of discovery. Was it a discovery? Yes and no, because it was just a simple thing that all physicists know, but it looked as if it was unknown, as so many courses on the subject still ignore it. How strange. If by simple and well-known concepts it is possible to explain a theory better than the way usually presented in books and courses, then why do people still keep these books as references, ignoring the possibilities to do better? Then I continued, trying to learn electromagnetism and general relativity. I had books on these subjects, from which I took some necessary information, but I didn't find there the understanding I was looking for. I only found the satisfaction of understanding later as a fruit of my own research, with my own notations. First, trying to understand electromagnetism. You know the usual expression of electromagnetism treats space and time separately, putting all three space coordinates together, forming vectors on the one hand, and letting the time coordinate just alone on the other hand. This is how it was expressed in the 19th century, when special relativity was not known yet, so that physicists were not aware that time and space had a common nature. But I didn't like that, as I knew that it was not the right picture of things. So, to really feel that I understood electromagnetism, I needed to see it in a way that treats space and time in the same manner. I managed to express electromagnetism in such a way usually ignored by books on the subject. I don't know why, as any physics student, knowing Maxwell's equations, can easily find it by taking these equations and separating the three space coordinates from each other. It is longer to write, it takes 8 big equations instead of 4 smaller ones, but then you can admire how space and time play similar roles there. This study of electromagnetism helped me to understand how, when treating space and time as similar, the energy density is just one component of a field with 10 components, including pressures. I used this to express the relation between energy and space-time curvature in general relativity, also with my own notations, when I was still 16. One key step of that research was to consider the case of the universal expansion. Now, that piece of reasoning is presented in my site, so you can follow it and understand this way the relation between energy and curvature with its justifications. Soon later, I expressed the forms of gravitational waves and spherical black holes, even with an electric charge. Then I made a little computer program showing a particle moving around the simplest black hole. All this just in my free time by my own research, as I was still in a standard high school. You can guess how much I was bored by the math lessons at school. Still, we may wonder if the understanding I had of electromagnetism was really better than the usual one. Indeed, as it was expressed in a coordinate system, it was not completely transparent to the symmetries of space. And for the same reason, its unification of time and space was not completely transparent either. So, it needs a more systematic treatment with short notations instead of long lists of coordinates, and more direct evidence that the choice of coordinates does not break the geometrical symmetries. The framework that makes this is already well known. It is tensor calculus that is needed everywhere in theoretical physics. It is not only necessary for the four-dimensional view of electromagnetism, for general relativity, and for quantum physics, but it can also clarify two important aspects of classical physics. One is vector calculus, used to describe solids, fluids, and electromagnetism in three dimensions. The other is screw theory, that describes the conserved quantities of mechanics. Some physicists may argue that, to express electromagnetism without separating space and time, we first need tensors. But we can't introduce them at the undergraduate level because this formalism is too obscure and difficult for that level. Indeed, I had a hard time trying to understand it. At some point, I had the chance to read the book Classical Theory of Fields by Landau and Lifshitz. This is a great book that helped me, but still I was not completely satisfied, and I kept searching for the best way to explain tensors. Actually, I found it not only very important, but also possible to explain tensors more clearly, to make this understandable to undergraduates. So it's a pity to see physics teachers either ignorant about how tensors can clarify classical physics, or knowing about this but assuming that the usual awkward presentation of tensors would be the only way. Either way, they let undergraduates struggle with expressions of theories that are inconvenient. And it's also a pity to see all authors of recent books and courses perpetuating this situation by still repeating the same traditional formulations of physics without question, ignoring that, through a careful global redesign, things could be made clearer. In fact, I don't claim my way to be the best for everybody, just a possible way, as not all students need the same kind of teaching. But a problem with the academic system is its intolerance, and its double passive assumption that there is only one right way that only varies somehow with geography, depending on the professor a student happens to be with. But moreover, that this one way is just given by what was already done in the past, without trying to wonder if another way would be possible or even better. But in the rest of this video, I will explain why I think these are not just exceptional problems to be fixed by some modifications in the curriculum, but symptoms of much deeper flaws in the academic system that cannot be resolved, and don't even need to be resolved, since it can be much better to get out anyway. Now, some people may dismiss this view as not serious, as it seems quite strange and bold. Indeed, I do agree. It is rather incredible to say that all these thousands of professors around the world just passively keep following an old teaching way, ignoring possibilities to do better. They are supposed to be the right people to know how to explain things and express that in their teaching. So, if they aren't, this needs an explanation. In fact, I understand such reactions, because many times such reactions would be right. I mean, there are many pseudoscientists out there who cry against the establishment, accuse scientists of conformism, and claim to have made wonderful discoveries that refute currently established theories. And usually, indeed, such fringe people are wrong, while the current theories of physics are really seriously well established. I have seen such claims, and how they are just nonsense. These people did not even understand the theories they claim to criticize. Their criticism of the scientific community is based on ignorance and paranoia. You know what? Some of these fools have high academic ranks too. But also, if there are so many fringe scientists who did not understand current science, but who think they can criticize it so easily, isn't it also because of these very troubles with teaching I'm telling you about? This huge discrepancy between the high quality of the scientific knowledge that exists for experts and the low quality of the teaching that is supposed to express this knowledge but doesn't do it properly. How can any reasonable person guess that scientists are serious and reliable in their research and knowledge if they don't behave seriously when expressing and teaching this knowledge to students? But you may say, even this combination of claims that scientists did a good work finding the right theories but a bad work teaching them is still incredible and terribly insulting towards professors who are often well-qualified people dedicated to their job. You know what? I agree that this is a terrible claim, very absurd, awful, incredible. it looks much nicer and more plausible to think that their teaching is good too. Yeah, much better assumption. You know what? I like it. Very interesting view. What? You are surprised? Why? Ah, you mean because I said that I oppose this view? But what's the problem? I like this view, I think it's very interesting, and I'm going to explain why it's wrong. Ah, because many people don't like to think about views they disagree with. But what can be the sense of a disagreement with something that you don't want to consider? You know, the truth is not a matter of what we like. It doesn't care. And something interesting in mathematical reasoning is the possibility to prove a result by contradiction. So, in order to prove that a claim is false, a good way can be to first accept it as true and then admire its logical consequences. One time I was traveling, I talked with a physics student, trying to explain that I have a way to introduce special relativity theory clearer than the usual way. But the reply was that they would not be interested, not just for the lack of time, but also because they already have an excellent professor in their university giving excellent lectures on this subject. I was a bit puzzled to hear this, as it seemed so exceptional, so I needed to check how it was actually done. So I asked for the text of this lecture. But then, you know what? There were no available written notes, no plan, nothing, because the professor was old and not familiar with computers. So I could not check how good or original it was. After all, it could be a wonderful lecture indeed. But, well, there is still something strange here. You know, it's not as if it was an industrial secret that needs to be kept to let a competitive advantage to the company. Because this is a public university, financed by the same education ministry supposed to care for the quality of teaching all around the country, and that also pays other professors in other universities to teach the same subject to other students. So, if the best lectures on this topic are made here, then what are all other professors teaching the same subject elsewhere supposed to be doing? Are they supposed to teach it in a not so good way, not knowing how the best one is doing, because he did not publish any notes? Because these other teachings are still better than nothing, probably. But, you know, the working time of a physics professor is a very precious thing. There is a lot of possible research that can be done for the progress of science and technology that needs many qualified physicists. And I guess that many of the same physicists, now good enough to teach relativity, but not doing it best, would still be good enough to be well demanded and well paid for other works. So, instead of wasting their time and a lot of public money in that teaching, wouldn't it be both cheaper for taxpayers and better for many students to just pay a cameraman and a few other technical assistants to record the best lectures being done, make transcripts, and then distribute these around the country? And why not also around the world after translation into other languages? You may say this can be done for pure lectures, but not for students' questions and interaction. Well, many defenders of the academic system like to philosophize about this. But seriously, I didn't see much worthy place for interaction when I was a student. Except, of course, for the many times I had to warn my teacher about the errors or omissions he made when writing on the blackboard the text of problems we were supposed to resolve. It is not very practical in a class with one teacher in front of a few dozen students, which divides the interaction time by the number of students, and I don't even see it as deserving much place in an ideal world. Or some students may need it, but not all, so why oblige them all to stay together in a class? I mean, a perfect lecture should be understandable without many questions, while for any meaningful question, the answer should be integrated in the lecture. Some students may need more explanations, so that a lecture in a website should contain links with possible questions and answers in separate pages for those who need. Once done, much of other needed interaction might just be tried between students before asking a teacher, so without any cost of teacher's work. Then, questions may be asked online and teachers may reply if still needed. But if it was so interesting for a student to observe other students interacting with the teacher, then why don't the videos of such interactions have more success than this on YouTube? So, on each subject, either there exists a perfect course publicly available or there isn't. If there isn't, then we need some original work to make a better one, closer to perfection. But this only needs to be done either once by one person or by a few people contributing to different aspects of the improvement. But they should form a team or use any method or technology such as a wiki to collect and compare their contributions so that they add up to form better and better versions of the course and not cancel each other. Anyway, the perfect course only needs to be done once. Then we come to the other case as concerns the rest of teachers around the world. If they cannot do better than the best, then they should repeat it, with no need to be original. But then, why take a qualified person to repeat it, if books, websites or videos can do it best already? And this is supposed to be one of the most qualified jobs in the world, the ultimate dream and vocation of many of the most intelligent, most original minds who are obliged to give many years of their life as students, all the energy of their mind just obeying and following the system, trying to prove how intelligent, original and knowledgeable people they are, but just for the purpose of getting the privilege to be considered good enough for just repeating. Just repeating like a machine, like the stupidest robot or TV set. But even worse, since a TV set can repeat a lecture perfectly, while a human's repetition cannot be perfect. So, one of the stupidest tasks in the world. Now, consider this question about quality education. Should the work of teaching be an original work or not? This is a very interesting political question to be discussed in the Ministry of Education. Because, well, that is what a Ministry of Education is here for. It has to take political decisions on how all teachers should work. But anyway, it has to treat everybody equally because, it's a national policy that should be right and fair to everybody, not making any discrimination between people. And so, to treat everybody in a fair manner, it must take the following decision. Either every teacher should be original, teaching to his students something completely different from what other students will learn from other teachers. But anyway, that's how they will all get an equal treatment. Or no teacher should be original, so they must all copy the contents of their lectures from each other without trying to think how good or bad it may be. Well, be careful. Only teachers should work like this, not students. Or we should continue like now, something in between these extremes, in order to combine the defects of both. So, teachers should copy their courses from each other because, well, from which other source do you think they should copy? Do you think the original copy should be written by the Ministry of Education? But why would the education ministers go to explain modern physics to teachers? That's not their job. The job of the education ministry is to administrate the academic system, taking political decisions on how to organize the work of all teachers to ensure the equality between citizens. The work of explaining physics is the job of the physics teachers. So, who should explain physics to the physics teachers then? Maybe high-level physicists should do it. One time, people of course don't know me, they cannot guess if my ideas for teaching modern physics better are serious. They oriented me to first contact some professors involved in the question, for peer review, In particular, I was told about a good physicist there who had written an article some years ago on a different way to teach relativity, so surely he must be a good authority we can refer to. I should contact him, so he can judge if my ideas are serious and then recommend me if they are. So, first I had a look myself at his article and saw, well indeed, this is different from the usual way. It's more geometric, but I could still see some big defects in his article. But to whom could I say this? I had to talk with him directly. Then, one day, I met him, so I tried to talk with him, but the discussion ended after 2 minutes. You know why? because he was not interested in the subject. He's a high-level physicist, so he has much more interesting problems to focus on than the question of how to explain some basic things. So you wonder, why did he care to write an article about it then? Because, of course, he was puzzled to see the terrible way in which relativity was being taught around him. So he needed to mention that there is something wrong with it, and it is possible to do it differently. But he never meant to be really interested in the question and to bother finding out what should precisely be the right way. This seems to be generally the case for most physicists. First, for their natural taste, they prefer to discover new results and explore the most difficult theories than clean up the basic concepts. I find it strange, as I love to find out the most perfect ways to understand not too complicated theories that play a fundamental role in the universe. Maybe they have painful memories of their learning efforts as students, to which after all they could adapt, but they wouldn't like to struggle again with this mess, or to understand how unlucky they were to have learned things in a way so far from the best possible way. Second, because of what determines the hierarchy in the university system, that is, the amount of specialized research publications disconnected from the quality of one's teaching. Because, once again, we need a grading system applicable to the whole academic community, and since it is not possible for every professor in the world to bring continuous revolutions to the teaching of the same basic theories, and since ideally anyway, teaching should be one of the stupidest tasks in the world, most professors need to show their originality in a way where many of them can be original and interest someone else, that is, in any one of thousands of specialized research subjects, each of which can just interest a few peer specialists. And maybe physicists just prefer to keep the virtue of humility. They need to be respected and praised by their peers to get good academic positions. So, how could they come to attack all professors in the world, saying, "Your way of teaching is wrong, and everybody must start teaching things in the new way I'm showing you," but still for the same salary, no matter how hard and disturbing it may be to change your teaching plans, because, again, this is public education, everyone is equal and must be paid the same way for the same amount of teaching. Or worse, you need fewer hours to teach this, so some downsize may be needed in your team. It would be foolish to try such a thing. Finally, in the whole academic system, are there any people interested in how to best understand modern physics? Yes, there are, but mainly in the philosophy of science sections. But philosophers have a different culture of what is interesting and how to work than scientists. Science aims to find the truth, so scientists care to discern what is right and what is wrong, to select the good quality works and to reject bad ones. But philosophers follow different purposes. They usually can't clearly know where the truth is, but they don't need to really discover anything anyway. They just need to discuss and philosophize on tastes and colors of ideas and what may be seen as the deep essence of things to feel that they are dealing with the most important things, the substance of the universe. But if philosophers of science do not actually produce useful discoveries, they still need to justify their jobs anyway. And so by necessity, they need to follow ways that can justify lifelong jobs for their large numbers. Namely, the larger diversity of opinions, the better. So, philosophers are tolerant and like to review what everybody thinks. Also, it is better to develop more obscure explanations with the perspective that it will require endless further comments and re-explanations than a final, perfectly clear and simple explanation that would close the debate on a given subject. Now, who can be interested to work in philosophy of science sections? There are many people looking for positions in the academic system. Some have the quality to be good scientists, but there are also many cranks interested in science who can't properly understand it, but they are very convinced of their ideas, and they need an academic position where they can develop and even teach their misunderstanding of physics. As they may have problems to fit with the community of physicists, they look elsewhere and easily find philosophers interested with their unconventional ideas. The result is that the community of philosophers of science is easily taken over by cranks who are there because they feel better there than with hardcore mathematicians and physicists. So, what's the picture? Physicists care for their specialized research, not for their teaching. Science teachers care to repeat things as faithfully as possible. Education ministries care to ensure that everybody gets equal rights and that many students get high diplomas. Science philosophers sometimes discuss how to understand physics, but usually don't deserve to be taken seriously. Students must prepare for their exams as they have no choice. Now the problem is there any pilot in the plane? And who cares? A huge lot of money is spent worldwide on education. Millions of students give many years of their life trying to learn science in the way it is taught. But does it interest anyone to wonder whether all this activity makes any sense and is going to the right direction? It seems not. There is a widespread social illusion to assume that if everybody works this way, it should be because it's a serious way to work. So we should trust and follow it, as who are we to disagree? But in fact, everyone is just trusting someone else who assumes that he trusts someone else who should be serious, but who in fact never really meant to guarantee that things were done right. Or if he did, it's not because he really knows it, but just because that's his job to pretend it, no matter what. So, if I claim that the teaching system is going to the wrong direction, I'm not making any extravagant claim, and I'm not contradicting anyone, because it has never been anyone's responsibility to ensure that the system was going right in the first place.